Hi everyone, it's Miss McCarrel. We're doing math today. We are going to be talking about something new called areas and arrays. So let's get started. Hi everyone. Okay, so we're going to start off with a little activity called a quick image. A quick image is kind of how it sounds. It's an image that I'll put up on the screen quickly, kind of like flash attack in math when we play a math game. So quick images, I'll put an image up and I want you to notice what do you notice about this photo? And I am asking a specific question of how many muffins are there in the photo, right? We're talking about math, so we'll be working with numbers. And I want you to pay attention to how many muffins there are. All right, here we go. All right, I'm gonna count to 3, and I want you to notice how many muffins there are and if you can see any patterns. 1, 2, 3. Okay, so like I said, how many muffins did you see? Can you hold it up with your hands? Can you show me with your fingers? How many muffins did you see? Right, there were, it's backwards on the screen. 6 muffins, okay? Now, I was wondering, how did you get to 6 muffins? Did you count each one by one? Or did you notice that there are 2 on top, 2 in the middle, and 2 on the bottom? Or did you count it by columns, the left column and the right column, each having 3? And all of that equals to 6 muffins. Now, what really good mathematicians do is they can write an equation. So hopefully you have a piece of paper in front of you. What I want you to do is to pause the video, and I want you to write an equation that goes with that image to show how many muffins there are. So for example, if I had, this is not pretty. It's okay. Okay, if that's what the image looked like, okay. Oh, and I notice, there's 2 on top, 2 in the middle, and 2 on the bottom. I can write an equation, 2 plus 2 plus 2. And how many muffins would that be? 6 muffins. All right. So now what we are going to do is a quick image activity. Quick image is exactly how it sounds, okay? Like I said before, a quick image is I'll put the image up of some cupcakes this time, and I want you to think, how many cupcakes are there? And be thinking of a strategy you can use that's more efficient than counting by ones, because I'm only putting it up for 3 seconds. All right, so be thinking how many cupcakes there are, what strategy did you use, and if you can write an equation down on your paper, what equation would you write? All right, here we go for 3 seconds. 1, 2, 3. Hi. So you might have noticed I changed outfits. I had all the videos made, but some of them got deleted. So it's the next day for me. So I was going to ask you, how many cupcakes did you see? What did you count by? Did you count by ones, by tens, by fives, by threes? To be more efficient counters. And can you, with a paper in front of you, write down an equation that goes with the number of cupcakes that you saw? Hi everyone! Okay, so I was thinking we could say on 3 what we got for our number of cupcakes. After that, we'll talk about some ways, some strategies that you used to get the number of cupcakes. And maybe thinking, how can I change my thinking if I counted by ones? Can I maybe be a more efficient counter and count by 2s or 5s? All right, let's see what we got on 3. 1, 2, 3. 30! We got 30 cupcakes. If you got 30, you are correct. If you didn't, pay close attention, then you can change your thinking. I need coffee this morning. Anyway, So now I want you to think, how did I get to 30 cupcakes? When you have an idea of how you got to 30 cupcakes, and when I say an idea, I mean, did you count by ones, by fives, by tens, right? How did you get to 30 cupcakes? Did you do multiplication? Okay, so when you have an idea, put a thumb on your chest. Nice. All right, so I'm going to show you a couple of strategies that you could have used. You could have counted, yep, by ones. 1, 2, 3, 4, 5, 6. But we know that's not the most efficient way you can count the cupcakes. Okay, so I'm going to teach you one way that you can do it. And if you didn't do it, if you did it a different way, then that's okay. So I noticed that there's 6 cupcakes on the top row. So I can assume that if there's 6 on the top, each row is going to have 6 cupcakes. So what is 6 5 times? 6 plus 6 plus 6 plus 6 plus 6 plus 6 equals 30 cupcakes. Did anyone do a multiplication problem? Maybe you did. I noticed that there are 6 cupcakes on each row, and how many rows are there? 1, 2, 3, 4, 5. So maybe you did a multiplication equation and you wrote 6 times 5, because 6 5 times is 30. Okay, so those are a couple of ways that you could have efficiently counted the number of cupcakes in the photo. Okay, so let's read our objective together on 3. 1, 2, 3. As a good mathematician, I can understand how to find and measure the area of an object. Hi, so today, like we said in the objective, we are going to talk a little bit about area. Now, you might be thinking, oh, I've heard that word before, or maybe you're thinking, no idea what that word is, and that's okay. So area is actually the measure of a space inside a shape. So like if you have a circle, the area of a circle is that space inside the circle. Same with a triangle. The area of a triangle, the area is measuring that space inside the triangle. And for right now, we're going to talk about the area of a triangle is equal to 1 unit. And that's how we're first going to talk about area. Okay, so I want you to look at this hexagon, the big shape below. And I want you to think, what is the area of this hexagon if we know for that the area of a triangle is equal to 1 unit? So we know a triangle is 1 unit, and so on. And we want to find out the area of the hexagon. Okay, so let's count together. If one triangle is 1 unit, we have 1, 2, 3, 4, 5, and 6. I was hiding that one with my little picture. So what is the area of this triangle? Of this hexagon, knowing that the area of a triangle is 1 unit. What's the area of this hexagon? Right. We know it's 6 units because we counted 1, 2, 3, 4, 5, 6. Nice work, class. Hi, everyone. Okay, so when you go into your blue student book, you are going to turn to page 84. Oh, nope, I don't know. There we go. Page 84. And what you are going to do is you are going to work on finding the area in units of each shape. And you're like, Ms. McCarrel, how do I do that? Well, you first have to know what is worth 1 unit. And it tells you up here, a triangle is worth 1 unit. So knowing that fact, you're going to find the area of each shape, the rhombus, the hexagon, and the trapezoid. Okay, and you are going to, basically there's a couple of options that you can do. You can cut out the triangle that I circled out of your own blue book and place it in the shape to see how many triangles it would take or how many units it would take to fit that shape. Or you can use your pencil, pen, crayon, whatever you're using to draw, and kind of visualize or picture in your head how many triangles. So like what I did for that one there, I drew a line to show each triangle because I know one triangle is 1 unit. So I can assume or I can estimate that for this shape, oh, that's not pretty, but for that shape, I can estimate that we have 1 unit right here and then 2 unit right here. So I would say the area is 2 units. And I want you to do that for each shape. Now, for the hexagon, it might be a little tricky. So something that I do is draw a dot in the middle and then draw my line. Because remember, we're doing this knowing that a triangle is 1 unit. So you can kind of figure out how many units is each shape. And it does get a little tricky, but I know you can do it, okay? And then this one is page 85. Okay, so I want you to kind of visualize and estimate if the triangle is worth 1 unit, what is the area of each shape? You can take a picture and send it to me, have a parent or caregiver send it to me, or you can post it in the Google Doc. But I want to see that you know how to find the area of these different shapes. Hi everyone! Alright, so like I said before, you can measure area in different ways. And like the last slide that we did, we measured our area in triangles as 1 unit. But I wanted to tell you that even though you can do that, most people usually measure area in square units, right? So, for example, a square is 1 unit, right? So this blue square we have right here is 1 square unit. Now I want to ask you, what is the area of this rectangle that I'm going to put up? And I wanted to mention, if you wanted to draw a shape and then figure out the area on your own, there is grade paper in your blue book. I can write down the page on page 87, and you're welcome to draw any kind of shape you want and then figure out the area. But from now on, when we talk about area, we are going to talk about measuring it in square units, okay? So for example, this little square we have here is 1 unit. Okay, so we're going to measure the area of a rectangle. Okay, so let's count together as we measure the area of this rectangle that we're going to make right now. 1, 2 square units, 3 square units, 4 square units, 5 square units, 6 square units. So what is the area of this rectangle? Right, it is 6 square units. Okay, so now that we've talked about measuring an area in square units, I wanted to talk to you about measuring the area of another shape, but with an added little challenge. So as you can see, we measured the area of a rectangle, right? And that area has 6 square units. But what if we add a new shape? What if we add this triangle? As you can see, these triangles do not fill the square all the way. So how do we measure that in units? Well, you might be thinking in your head, well, Miss McCarrel, I think if we put the 2 triangles together, it would make 1 square unit. Okay, so let's try. Boom! It makes 1 square unit. So what is the area of this shape? Let's count. 1, 2, 3, 4, 5, 6, 7. The area of this shape is 7 square units. If you don't know how to find the area, like if it's a triangle, you can try to put the shapes together to make 1 square unit. That is a really good strategy to find the area of different shapes. And that is what you're going to do as part of your activity on page, let me get this. Oh my gosh. Page 86, it is going to ask you, knowing the fact that a square is 1 unit of area, what is the area of these different shapes? And you're probably thinking, oh, Miss McCarrel, I know. Like for this one, I bet you could figure it out pretty efficiently. You can draw lines to help you. Don't do the lines like I did. Those are not good lines. But you can draw lines to make 1 unit of area and then count how many square units you have for that shape. But like I said before, it might get a little tricky. For example, this one, you have to put the shapes together to make 1 unit of area. Right? So for example, you got to put those triangles together and that makes 1 square unit. Okay? So you got to put it together and then figure out the area of each of these shapes. I want you to fill it out and either take a picture of it and send it to me or post it in the Google Doc. But part of what you're supposed to know in 2nd grade is finding the area of a shape. Okay? So kind of to wrap up what we know about area, I wanted us to do a last final activity together. Okay, so I want you to look at this shape that I made, this rectangle, and I want you to tell me what is the area of this rectangle. And you might be thinking, oh, I know, Miss McCarrel, it's But I want you to also think, what equation can you write to go with your answer of the area? Okay, so just shout out before we even start counting the area, just shout out estimates, right? Estimate means your best guess. So for example, I'm looking at this shape and I'm thinking, okay, I'm thinking 15 square units. I'm thinking 5 square units. Oh, thank you. Okay. Well, that was someone from the audience who said it was 5 square units. Do we have any other guesses? How about 18? These are all really great choices. Wow, whoever is saying those choices is pretty great. Okay, so we got, oh my gosh, that is not an 8. Okay, there you go. So we have some estimates, right? Remember, really good mathematicians can estimate before they actually measure an object or measure the area of an object. Okay, so now we can figure out the area and write an equation to go with the area. Okay, so remember, really good mathematicians find efficient ways to count. We don't just count by ones, right? we're super cool and we try to count by bigger numbers so we can get to the end more efficiently. So I notice in this row that there are 1, 2, 3, 4, 5 in that row. So I can skip count by 5s until I get to the end. So can we do that together? Let's skip count by 5s until we get to the end. So we have 5, 10, 15, 20. So how many square units is our rectangle? Say on 3. 1, 2, 3. 20 square units. Nice. Now, bonus points. Can you write an equation to go with the strategy you use to find the area? So for example, if I skip counted by 5, how many times did I count by 5? Right, I counted by 5 4 times. So that is a multiplication equation. 5 times 4 is 20. You can also do what's called repeated addition. That means you're adding over and over again. 5 plus 5 plus 5 plus 5 is 20. Or maybe you did it by the column. Maybe you went 4 plus 4 plus 4 plus 4 plus 4 is 20. Whatever strategy you used, I want you to write it down in your blue book. You can draw this shape on your grid paper on page 87, and then underneath, or wherever you have space, you can write down an equation to go with your strategy that got you the area. Okay, I feel like I just spoke a lot of words, so I'm going to stop while I'm ahead. Okay, so like I said, your next step is to work on page 84, 85, 86, and 87 is just grid paper. So those 3 pages, okay? That's going to really help you understand areas and arrays, okay? Now, I also want you to practice areas and arrays in IXL, okay? And I recommended 5 different skills for you to do. So you can either identify repeated addition in arrays, like we talked about before, like 5 plus 5 plus 5 plus 5. You're going to write an addition equation or addition sentence for arrays. You're going to select figures with a given area. So you're going to have a shape, and then you're going to match the area to that shape. And then you're going to create a shape with an area that they give you. You're also going to create a rectangle with a given area. So basically it's everything we've talked about, and I really want you to practice, because that's what second graders, that's what you're going to have to know for next year. So, and remember, you're still in school, so keep practicing. Finish the pages and either text it or put it in the Google Doc, and then work on IXL. 20 minutes every day. This is something brand new, but I know you can do it, and if you have questions, always reach out. Thank you, mathematicians.